Flight crew procedures. Review NOTAMs to make sure that the destination airport still meets visual or non-visual CAT-EL or CAT-3 requirements, runway and approach lighting, radio nav aid availability, RVR equipment availability. Aircraft status, check that required equipment for CAT-2 or CAT-3 approaches are operative. The required equipment list is given in the FCOM and in the AFM. Crew qualification and currency must be reviewed. Both captain and first officer must be qualified and current. Weather information, check that the weather forecast at destination is within airline and crew operating minima. If the forecast is below CAT-1 minima, verify that alternate weather forecasts are appropriate to the available approach means and at least equal or better than CAT-1 minima. Fuel planning, additional extra fuel should be considered for possible approach delays. Approach preparation. Aircraft status. Check on the CAM status page that the required landing capability is available. Although it is not required to check equipment that is not monitored by the system, if any of this equipment is seen inoperative, flag. The landing capability will be reduced. For A300/A310, check auto land warning light. Weather, check weather conditions at destination and at alternates. Required RVR values must be available for CAT-2 and 3 approaches. The selected alternate must have weather conditions equal to or better than CAT-1. Approach ban. Policy regarding an approach ban may differ from country to country. Usually the final approach segment may not be continued beyond the outer marker or equivalent DME distance if the reported RVR is below the published minima for the required transmissometers. After outer marker or equivalent, if RVR becomes lower than the minima, the approach may be continued. ATC calls, unless low visibility procedure are reported active by Automatic Terminal Information Service ATIS, clearance to carry out a CAT-2 or CAT-3 approach must be requested from ATC, who will check the status of the ILS and lighting and protect the sensitive areas from incursion by aircraft or vehicles. Such an approach may not be undertaken until the clearance has been received. Before the outer marker, the required RVR values should be transmitted. Seat position. The correct seat adjustment is essential in order to take full advantage of the visibility over the nose. The seat is correctly adjusted when the pilot's eyes are in line with the red and white balls located above the glare shield. Use of landing lights at night in low visibility conditions. Landing lights can be detrimental to the acquisition of visual references. Reflected light from water droplets or snow may actually reduce visibility. Landing lights would therefore not normally be used in CAT-2 or CAT-3 weather conditions. The briefing should include the normal items as for any IFR arrival, and in addition the following subjects should be covered prior to the first approach: destination and alternate weather, airfield and runway operational status CAT-2, CAT-3, etc. Aircraft systems status and capacity, brief review of task sharing, review approach procedure, stabilized or decelerated, review applicable minima, go-around procedure, ATC calls, brief review of procedure in case of malfunction below 1,000 feet, optimum seat position and reminder to set cockpit lights when appropriate. Approach procedures. Task sharing CM1 and CM2 task sharing must be clearly defined in the Airline Operations Manual. The recommended task sharing for a CAT-2, CAT-3 approach is that CM1 is pilot flying and CM2 is pilot non-flying. All CAT-2 and CAT-3 operations, CM1, has hands-on controls and thrust levers throughout the approach, landing or go-around, makes FCU selections, if any, takes manual control in the event of autopilot disconnection, monitors flight instruments. Approaching decision height, starts to look for visual references, progressively increasing external scanning as decision height is approached. If no decision height procedure is used, the pilot flying will nevertheless look for visual references. At or before decision height, if his decision is to continue, calls continue, scans mostly head up to monitor the flight path and flare, in Cat 2 or Cat 3 Alpha, or the position on the runway, in Cat 3 Bravo, by visual references, monitors thrust reduction or for Airbus 320 Airbus 330 Airbus 340, at retard callout, sets thrust levers to idle, selects and controls reverse thrust, disengages autopilot when taxi speed is reached. CM2, monitors flight instruments head down throughout approach, go around or landing until rollout is completed, calls any deviation or failure warning, calls barometric heights as required, and monitors auto callout or calls radio heights including 100 above, monitors FMA and calls mode changes as required. At decision height, identified by oral and visual warning, if decision is not announced by CM1, calls minimum, if no response from CM1, initiates a go-around. Cat 3 operations without decision height CM1, if no failure by alert height, calls continue, monitors flare by flight instruments, monitors lateral guidance during flare by yaw bar on PDF, monitors automatic ground roll by scanning alternately instruments and external references. All Cat 2 and Cat 3 operations if decision is to go around. CM1, calls go around, flaps, initiates go around by setting thrust levers to toga, or triggering go levers for Airbus 300 Airbus 310, monitors rotation on PFD, checks positive climb, vertical speed and radio altimeter, commands configuration changes. CM2, standard operating procedures. Landing checklist.
Landing checklist cabin crew.
Advised.
Auto thrust.
Speed.
Auto brake.
Medium.
ICAM memo.
Landing no blue.
Landing checklist completed.
Land.
Checked.
300. 200. 100 above.
Checked.
100. 70, 60, 50, minimum 40,
continue.
30, 20.
Flare.
Retard.
Roll out. Spoilers. Reverse green. D's. 70 knots.
Checked. All-weather operation. Introduction. General concepts. How to get approval. Aircraft requirements. Airfield requirements. Operational approval. Low visibility takeoff. Introduction. This module discusses all aspects of Category 2. Category 3 and low visibility takeoff operations, which are the main part of all-weather operations. The term all-weather operations also includes Category 1 operations, and taxiing in low visibility, as shown below. Cat 2 definitions. The Category 2 is a precision approach corresponding to weather minima as mentioned here below. ECHO definition. A Category 2 approach is a precision instrument approach and landing with decision height lower than 60 meters, 200 feet, but not less than 30 meters, 100 feet, and a runway visual range not less than 350 meters, 1,200 feet. FAA definition. A Category 2 approach is a precision instrument approach and landing with decision height lower than 200 feet, 60 meters, but not lower than 100 feet, 30 meters, and a runway visual range less than 2,400 feet, 800 meters, but not less than 1,200 feet, 350 meters. JA Definition A Category 2 approach is a precision instrument approach and landing with decision height lower than 200 feet, 60 meters, but not lower than 100 feet, 30 meters, and a runway visual range not less than 300 meters, 1,000 feet. Cat 3 A definitions ICA and FA. A definition A Category 3 A approach is a precision instrument approach and landing with no decision height or a decision height lower than 100 feet, 30 meters, and a runway visual range not less than 700 feet, 200 meters. JA Definition A Category 3 A approach is a precision instrument approach and landing with a decision height lower than 100 feet, 30 meters, and a runway visual range not less than 700 feet, 200 meters. It is worth noting that the JA considers that Cat 3A is always associated with a decision height difference with ICAO, FAA. Cat 3B definitions ICAO and FA. A definition A Category 3B approach is a precision approach and landing with no decision height or a decision height lower than 50 feet, 15 meters, and a runway visual range less than 700 feet, 200 meters, but not less than 150 feet, 50 meters. JA Definition A Category 3B approach is a precision approach and landing with no decision height or a decision height lower than 50 feet, 15 meters, and a runway visual range less than 700 feet, 200 meters, but not less than 250 feet, 75 meters. Notes: ICAO, FA and JA differ by the minimum RVR associated with Cat 3B approaches, 50 meters, 75 meters. JAA, where the DH and the RVR do not fall in the same category, the RVR will determine in which category, Cat 3A or B, the operation is to be considered. Cat 3C definition ICAO and FA. A definition A Category 3C approach is a precision approach and landing with no decision height and no runway visual range limitation. Cat 3C operations are not currently authorized and the JA does not mention this subcategory. Decision height definition. Decision height is the wheel height above the runway elevation by which a go-around must be initiated unless adequate visual reference has been established and the aircraft position and approach path have been assessed as satisfactory to continue the approach and landing in safety. JAR. For Cat 2 and Cat 3A, a pilot may not continue the approach below decision height unless a visual reference containing not less than a 3-light segment of the centerline of the approach lights or runway centerline or touchdown zone lights or runway edge lights is obtained. For Cat 3B, the visual reference must contain at least one centerline light.
Approach lights. Check.
$100, $50, $40, $30, $20, $10. Retard. Retard.
Decision height concept. Decision height is a specified point in space at which a pilot must make an operational decision. The pilot must decide if the visual references adequate to safely continue the approach have been established. If the visual references have not been established, a go-around must be executed. If the visual references have been established, the approach can be continued. However, the pilot may always decide to execute a go-around if sudden degradations in the visual references or a sudden flight path deviation occurred. In Category 2 operations, decision height is always limited to 100 feet or obstacle clearance height, whichever is higher. In Category 3 operations with decision height, the decision height is lower than 100 feet, typically equal to 50 feet for a fail-passive automatic landing system and 15 to 20 feet for a fail-operational automatic landing system. Alert height is a height defined for Category 3 operations with a fail-operational landing system. Above alert height, a go-around must be initiated if a failure affects the fail-operational landing system. The list of these failures is mentioned in the aircraft flight manual. Below alert height, the approach will be continued, except if auto-land warning is triggered. The alert height is evaluated during aircraft certification. It is set at 100 feet for Airbus 300, 310, 320 family, and 200 feet for Airbus 330, 340. Fail-passive automatic landing system. An automatic landing system is fail-passive if, in the event of a failure, there is no significant out-of-trim condition or deviation of flight path or attitude but the landing is not completed automatically. For a fail-passive automatic landing system, the pilot assumes control of the aircraft after a failure. JAA. On Airbus aircraft since the Airbus 320, fail-passive capability is announced by the display of Cat 3 single on the PFD. Fail-operational automatic landing system. An automatic landing system is fail-operational if, in the event of a failure below alert height, the approach, the flare and landing can be completed by the remaining part of the automatic system. In the event of failure, the automatic landing system will operate as a fail-passive system, JAA. On Airbus aircraft since the Airbus 320, fail-operational capability is announced by the display of Cat 3 dual on the PFD. Operations with decision height. It should be stressed that the decision height is the lower limit of the decision zone during which, in limiting conditions, the CM1 will be assessing the visual references. CM1 should come to this zone prepared for a go-around but with no pre-established judgment. CM1 should make a decision according to the quality of the approach and the way the visual references develop as decision height is approached. A. Cat 2 operations. In Cat 2 operations, the conditions required at decision height to continue the approach are that the visual references should be adequate to monitor the continued approach and landing, and that the flight path should be acceptable. If both these conditions are not satisfied, it is mandatory to initiate a go-around. The visual references required at decision height in Cat 2 operations to continue the approach may be any of the following: a segment of the approach light system, the runway threshold, the touchdown zone.
B. Cat 3 operations. In Cat 3 operations with decision height, the condition required at decision height is that there should be visual references, which confirm that the aircraft is over the touchdown zone. Go-around is mandatory if the visual references do not confirm this. Cat 3 without decision height. For this category of operation, the decision to continue does not depend on visual references, even though a minimum RVR is specified. See operating minima. It is nevertheless good airmanship to confirm aircraft position with available visual references. However, the decision depends only on the operational status of the aircraft and ground equipment. If a failure occurs prior to reaching the alert height, a go-around will be made. A go-around must nevertheless be performed if the auto-land warning is triggered below alert height. Loss of visual references. A. Operations with decision height. Before touchdown, if the decision to continue has been made and the visual references subsequently become insufficient for the appropriate category, or the flight path deviates unacceptably, a go-around must be initiated. A go-around initiated below the minimum approach break-off height, whether auto or manual, may result in ground contact. Note: if the touchdown occurs after go-around is engaged, the autopilot remains engaged in that mode, and ATHR remains in toga. Ground spoilers and auto brake are inhibited. B. Operations with and without decision height. After touchdown, if the visual references are lost after touchdown, a go-around should not be attempted. The rollout should be continued without in rollout mode down to taxi speed. Flight parameters deviation calls. These calls would normally be made by the pilot non-flying and acknowledged by the pilot flying. However, any crew member that sees a deviation outside the above limits should make the appropriate call. If any of these limits are exceeded approaching decision height, a go-around should be considered.
Failures and associated actions. In general, there are three possible responses to the failure of any system, instrument or element during the approach. Continue the approach to the planned minima. Revert to higher minima and proceed to a new decision height, above 1,000 feet. Go around and reassess the capability. The nature of the failure and the point of its occurrence will determine which response is appropriate. As a general rule, if a failure occurs above 1,000 feet AGL, the approach may be continued reverting to a higher decision height, providing the appropriate conditions are met. Refer to downgrading condition. Below 1,000 feet, and down to alert height when in Cat 3 dual. The occurrence of any failure implies a go-around, and a reassessment of the system capability. Another approach may then be undertaken to the appropriate minima for the given aircraft status. It has been considered that below 1,000 feet, not enough time is available for the crew to perform the necessary switching, to check system configuration and limitations and brief for minima. In Cat 3 dual, in general, a single failure, for example one autopilot failure or one engine failure, below alert height does not necessitate a go-around. But a go-around is required if the auto-land warning is triggered. The abnormal procedures can be classified into two groups. 1. Failures leading to a downgrading of capability is displayed on FMA and ECAM with an associated specific audio warning, triple click. 2. Failures that do not trigger a downgrading of capability but are signaled by other effects, flag, ECAM warning, amber caution and associated audio warnings. It should be noted that some failures might trigger ECAM warnings, cautions and a downgrading of capability. Above 1,000 feet, downgrading conditions. A. Downgrading from Cat 3 to Cat 2 is permitted only if ECAM actions are completed. VR is at least equal to Cat 2 minima. Briefing is amended to include Cat 2 procedure and DH. Decision to downgrade is completed above 1,000 feet AGL. B. Downgrading from Cat 2 to Cat 1 permitted only if ECAM actions are completed. At least one flight director is available. VR is at least equal to Cat I minima. Briefing is amended to include Cat 1 procedure and decision height. The decision to downgrade is completed above 1,000 feet AGL. Note: switching from one autopilot to another before 1,000 feet AGL is permitted. Below 1,000 feet and above decision height, for Cat 2 or Cat 3 single, or above alert height. For Cat 3 dual, a go-around must be performed in case of alpha floor activation, loss of AP, cavalry charge, downgrading of capability, triple click, amber caution, single chime, engine failure. At 350 feet radio altitude, land must be displayed on FMA and runway course must be checked. If runway course is incorrect or land does not appear, a go-around must be performed. If conditions permit, and according to airline policy, a Cat 2 approach with autopilot disconnection no later than 80 feet may be performed. Land is displayed if localizer and glide slope track modes are active and at least one RA is available. These conditions need to be obtained no later than 350 feet AGL to allow a satisfactory automatic landing. Depending on terrain profile before the runway, land mode may appear at lower height. This can be acceptable provided it has been demonstrated that automatic landing is satisfactory. At 200 feet and below, any auto land warning requires an immediate go-around. If visual references are sufficient and a manual landing is possible, the PF may decide to land manually. At flare height, if flare does not come up on FMA, a go-around must be performed. If visual references are sufficient and a manual landing is possible, the pilot flying may decide to complete the landing. After touchdown, in case of anti-skid or nose wheel steering failure, disconnect autopilot and take manual control. If automatic rollout control is not satisfactory, disconnect the autopilot immediately. Low visibility takeoff. Takeoff with RVR less than 400 meters is considered as low visibility takeoff by JAR OPS-1. The maximum RVR at takeoff is quite independent of the aircraft type and aircraft equipment except for very low RVR. The takeoff minima is mainly determined by the airport installation, runway lighting system, RVR measurement system. When weather conditions are more severe than the landing minima, a takeoff alternate is normally required, within 1 hour for twins, within 2 hours for quads, within the maximum approved diversion time for aircraft qualified for ETOPS, but not more than 2 hours, JAR OPS. Above time is determined at the one engine in operative speed. Low visibility takeoff with RVR between 400 meters and 150 meters. The minimum RVR in this range of value is a function of the aircraft category and of the runway equipment. Note, the requested RVR value representative of the initial part of the takeoff run can be replaced by pilot assessment. No operational approval is required to perform a low visibility takeoff with these minima according to JAR OPS-1. Low visibility takeoff with RVR between 150 meters and 125 meters. JAR OPS-1 has provision to further reduce the minimum RVR provided the airline has obtained an operational approval to conduct low visibility takeoff with this minima. Among the conditions which must be met, one is related to the aircraft type. A visual segment of 90 meters is required from the cockpit during the takeoff run with the minimum RVR. The visual segments for RVR 125 meters are given in the table below for each Airbus model. Consequently, all Airbus models have the capability to be operated with 125 meters RVR at takeoff. Additional requirements are as follows. Low visibility procedures are enforce high-intensity runway centerline lights spaced 15 meters or less and high-intensity edge fights spaced 60 meters or less are in operation. The 125 meters RVR value has been achieved for all of the relevant RVR reporting points. Flight crew members have satisfactorily completed training in a simulator approved for this procedure. Low visibility takeoff with RVR between 125 meters and 75 meters. JAR-OPS-1 has provision to authorize takeoff with RVR between 125 meters and 75 meters provided the aircraft is equipped with an approved lateral guidance system and an operational approval has been obtained by the operator. Such systems have been certified on Airbus aircraft and have been installed in option WGD windshield guidance display HUD head-up display PVI visual indicator. All these systems provide the pilot flying with a lateral guidance using locked signal. This kind of display allows the pilot to follow the guidance orders and to continue the monitoring of external visual cues, centerline lights. The FD lateral guidance indication alone is not considered to be in itself an acceptable means. With above-mentioned optional systems, Airbus aircraft can be operated at takeoff with a minimum RVR of 75 meters, as indicated in the AFM, provided runway facilities are equivalent to Cat 3 landing capabilities and ILS protections are active. CM1. Head-up runway centerline. Visually follow visual cues remain the primary means to track the runway centerline. The yaw bar provides an assistance in case of unexpected fog patches. CM2. Head down yaw bar, ILS monitor flight and engine instruments monitor speeds call rotation monitor deviations monitor, advise PF in any deviation occurs. Pilot flying head-up at all times keep, while aircraft is moving. Taxiway and runway chart keep available, for quick reference when the aircraft is stopped. Pilot non-flying airfield plates, OIUs. Taxiway headings and upcoming turns advise. Ground speed monitor. Taxi out and before takeoff in low visibility operation. No checklists or administrative work should be conducted whilst taxiing in low visibility. Never cross a red stop bar when lining up or crossing a runway, unless it has clearly been reported as being unserviceable, or on test, and unambiguous clearance to cross has been received by ATC. If unsure of position, the aircraft should be stopped and the parking brake set. ATC may provide assistance by use of ground radar or transponder interrogation or by sending a follow-me car. Bear in mind that, whereas bright lights may be visible, until obstacles and aircraft extremities may not. Stopping an aircraft, even at very low taxiing speed, can be surprisingly long.